Hey everyone, welcome to the first video in the Telegram LibGDX AI tutorial series. So with this video, we're going to be covering some approaches to applying the Telegram message system. And what the Telegram system does is it allows us to create a more effective event-driven game. And it's always good to have event-driven projects because it makes things easier to transition to different states in your game. It also is easier to control the flow of when things happen. It allows things to be a little more asynchronous. And that means you can do a lot of stuff off to the side and not have to worry about doing all the heavy lifting and intermingling all this spaghetti code. You can just tell your message dispatcher, hey, this happened, tell other people about it, and then everyone who is listening to the message dispatcher will receive the message if they're supposed to be listening, and they'll act accordingly. And just with that simple idea, you can really get a lot out of it. Now, it doesn't just have to be on the visual side of your game, as we'll see later in future parts of this series, and but you can use it for game mechanics as well, such as like player input or controlling the way your animations work and like the state machines in your entity classes. You can control the way your game screen manager works. You can control the win or lose occurrence. So like, let's say a player gets to the end of a level, then the player will be like, hey, I got to the end of the level, message dispatcher, can you please let the game screen know? And that way, you don't have to hard code a lot of like, okay, is the player in this X and Y? Okay, is this condition true? Is this condition true? And you can just say, hey, message dispatcher, send out this message, and whoever's listening, good for them, you know? And then the message dispatcher, sorry, that's a little bit of a word jumble. Message dispatcher will let the people that are listening to that particular message know about it, that it has occurred. I received this message, and then the screen will act accordingly and end the level, and everything will kind of shut down as it needs to as you program it. So we'll see that there are essentially like 3 steps to getting this set up, which is actually pretty nice in comparison to some of the other AI parts in the library. And it all comes down to creating and managing your instance of your message dispatcher and adding all the listening agents of the types of messages that are available. And then 3 is just sending out messages and acting on messages. So it's fairly straightforward once you actually get into it. And for this particular example, I just have this box 2D world, and you can see that when I open it up, there's a loading screen, and we're in this gray world, as we've seen in many other videos that I used to demonstrate projects. So we have a camera, a HUD for displaying the text in the bottom left, we have a world, box 2D debug render, and we do all the regular stuff that I'm hopefully sure most of you have seen before. And that's about it. That's all that's really going on in here. So with that, let's get started and jump into getting our message dispatcher set up. So there are 2 ways to go about this. There is you can create your own message dispatcher. You'll see that this is a class that you can pull in, and with that, you can create your own different message dispatcher, like your own instance of it, and you can have several of them. So with several message dispatchers, you're able to have, let's say you have a large set of messages that can be heard. However, not all of them are related to the same subject. So like, let's say you have some kind of audio manager message dispatcher, you have some kind of screen manager message dispatcher, or animation or control, or any kind of thing like that. Like, you have a lot of these messages that really shouldn't intermingle, and there's no reason that a game screen manager should be hearing about audio manager messages. So that's what you would kind of use like different message dispatchers for, but only for the intensive purpose of, or the intent and purpose of large sets of messages. So with that in mind, we're going to use the regular approach, which is just getting the message manager, as you see here. We're just going to call this MSG manager, just for our own shorthand. And so now that we have that, we're going to come down to our show method, and I'm going to create a method called init messages. And then at the very bottom here, I'm going to create it. So private void init messages. And then in here, we're going to fetch our message manager. And so this is the part I was talking about. There's, as I said, there's different ways to have a message dispatcher. And the message dispatcher in general is just like the overall thing that's going to be handling all these messages. It's going to be passing them out and receiving messages as it gets them. So think of it as like the post office. It's getting these telegrams. And that's kind of like where the idea comes from. Telegrams at a post office, old-timey stuff like that, passing around messages to people and receiving messages from people. You can have your own, or you can just get the static one, which, as you see popped up right away, is message manager.getInstance. So if you're not familiar with static, or not static, but singleton instances, I do recommend looking that up. It's a great design pattern to work with, although don't be careful with it sometimes. But yeah, it basically gets us the same instance every time from a static context. So it'll always return me the same instance that I've used the second it's created. So now that I'm calling this once, it'll make that message dispatcher for us, and it's going to use that one for the rest of our project anytime I ever call this getInstance method. So you can kind of think of like if I have message manager.getInstance dot dispatch message 00, and we'll see what that means later. This is pretty much the same as saying this. So this and this are equal from now on, because I made a reference to it here, and that message manager.getInstance is always going to be the same one the first time I call it. For every other time that I call it, it will be the same as the first instance. So now that that's clarified, and we have our message manager, this is what's going to be our main post office. We are going to be dishing messages in, and it will dish messages out. And so now we need an object to work with. So what I've created is this person class, and in this person class, I have a few things set up already. As you'll notice, I have a name, I have a box2D body that I gave it, I have a vector2 travel position, which is the position that the body should be in, and you'll see how that's used later. I have this freeze boolean, and the constructor takes in a name and a body, and it sets them as it should, and it sets the initial travel position to the initial location of the body that it was given. So in the update method that it has, you'll notice that if freeze is false, then I tell the body to move at a certain speed, and I'll actually change that speed a little lower. So what I'm doing here is I'm saying if the body is like these 4 if statements here, if the body is not at the travel position, then pretty much move to that travel position. It's a little more verbose way of saying that. But otherwise, if we are frozen, then don't move to that position. Just stay where you are for now until you're not frozen anymore. So that's all I have set up right here, and we're going to be using some of these conditionals to help us coordinate kind of this automated or message system so we can see it in action. So I'm going to be doing things like, okay, go to the left position or go to the right position, and I'll send these messages to this person, and this person will interact with the game world based on the messages it receives. And so in order to do that with this person, you need to extend the Telegram state or class. And so the telegraph, that should be implement. Sorry about that. So when you implement that, it has a method that you need to implement called handle message. And that handle message takes in a telegram, and the telegrams are pretty much the messages that the message dispatcher or the message manager is going to be dishing out to all the entities that are telegraphs. So telegraphs can send and receive messages. And with that, you'll notice it returns a Boolean false. If it returns false here, that means no messages were handled, and that means the return message is still false for this particular telegraph. So just to kind of do a small recap here, we have our Telegram manager. He sends out and takes in telegrams, and then we have telegraphs that can send and receive telegrams and act on them. So then you also have telegrams, which are the messages that are being sent and received. So those are kind of like the three big ideas to this, is just those three classes: telegrams, telegraphs, and telegram dispatcher. So now that we have this method, let's start getting things set up in our main screen here. So in our show method, let's have a init. So init person, and we're gonna create a new person up here. So person, and we'll call him Bob. So that is just Bob person. So then we can come down here, private void init person Bob equals new person. I'll call him Bob, and then he needs a body. And so I have a utility class called B2D bodybuilder, which I'm going to use the create box method, and that'll just create a box2D body box for me. And so it's going to be B2D bodybuilder dot create box world, and then I have to give it an X, and that's going to be 0, and a Y, that's going to be 0. So the center of our screen, and a width, I'm going to set that to 32 and 32 for width and height. It is not a static object, and it is not a sensor body. So that's what this method has in it right here for the arguments, by the way. You can pause to review this code real quick if you like. It's just a static method in a final class that allows you to create a box body. So with that, Bob now has a body to work with, he has a name, and he is in our world, because that happens when I send the world to the create box. So now that we have Bob, because Bob is an object of the person class, he implements the telegraph, and he has this handle message method that he takes care of for listening on the message dispatcher. So in order for him to be able to listen for messages, however, we need to make sure that the message manager assigns him messages that he's allowed to listen for. So this is kind of like, okay, I am the post office. I tell people what mail they're allowed to receive, or like I set up the boxes that messages go to for the entities. So we need to do a few things for our init messages, or yeah, you know what? I should actually switch these around. So we're going to go to our show method. We're going to move this init persons above init messages, so we can start working with Bob in the init messages. So he can start. So the message manager can start getting messages set up to be sent out to people. So in that, we need to have messages that Bob is going to be listening to. If you remember, in person, we have some movement stuff that's going on. Now, We don't really have influence over this as far as like controller input. We can't control how fast he's moving. We can't control like which direction specifically he's going. We can only tell him when his travel position changes, essentially. And to do that, we're going to use messages to coordinate his movements to these places. And so I created another utility class. I put it in my utils, and I called it message type. So you'll notice it's a final class. It has a private constructor because it's not really an object. You can't use enumerators, unfortunately, to use as messages, which would be nice for shorthand. However, you can just say message type dot go down by making these all public, static, final ints. And this is kind of where you'd classify them in separate classes, such as like in the manager classes, you would have these sort of, the messages that would be available for those classes, and then you create the separate message dispatcher for those classes. However, because we're just going to be using the regular instance, we can just keep piling up the messages we have in here. And so you'll notice I have 4, 5, 6, 7 different messages, and they all go from 0 to 6. They all need to be different because message dispatchers only use unique int or integer IDs as the message type that it's sending. So if you pass it a 0, that means it's only gonna recognize it as a 0. Or I'm sorry, if you pass it as go down and you also send it a 0 anytime you're passing a message, it'll still recognize it as the same go down message. It doesn't really change it. If you send a 0, it's going to be a 0 as far as the message goes. So that's all that looks for. And so with these different messages, we can go to our handle message in the person object, and we can start making some revisions here. So if you an easy way to go about this is, you'll notice we get a Telegram message, and Telegram messages have several methods and public variables that you're able to see. And you'll notice there's this int message that we're going to be using, and that's kind of how you tell which one of these message types have been sent to this object. So with that, I'm just going to use a switch statement, and we can do message.message, or I'm sorry, msg.message, and then we can have several cases. So message type dot go down, break for now. Just copy and paste a lot of that. So go down, go up, go left, go right. And then we can also have the other ones, so like say message, and then what else? There was continue moving, and then stop moving. Okay, so those are all the message types we have, and so it'll kind of do this switch. Okay, so I got 0 through 6. So it could be any one of these 6 messages that I'm allowing the person class to listen for. Or rather, not listen for, but handle. So when it receives a message, it'll be like, okay, these are the possible ones that I know how to handle, and it will just go through here, and then it'll act accordingly once it receives them. So what I'm going to be doing for the easiest case is the say message. The say message is just going to say the name or some kind of phrase or something. So first off, we need to have it return true because the message is getting handled. And so in here, we're going to do a simple print statement. This is going to be the easiest of easy messages. So, hi, my name is, and we'll have him print out his name, and that's it. So that'll just get printed to the console the second he receives the say message telegram. from the message dispatcher. So we can go back into our Telegram screen, and as I was saying, in order for Bob to be able to listen for these messages, we need to make sure that the message dispatcher sets up that little post office box for him. So this message manager add listener, and then because it says a telegraph and a message are the parameters, because Bob is a telegraph and the message that we want is message type dot say message. Now Bob will be listening for this message in the message manager. So anytime the message manager receives the say message type, then Bob will act accordingly. And in order to test this, we are going to come up to our handle input method and create a little if statement. And so it's going to be gdx.input.keys, or is key just pressed, and that's input.keys.space import input. And then we're going to say this message manager dispatch message, and we're going to say message type and you'll notice there's like a ton of different methods. We're going to be going into quite a few of these, probably not all of them, because it's easy enough just to look up the API and the SDK docs online. However, it's always good to see what some of them do and how to use them in an effective manner. So you'll notice we have our 6 that we're allowed to use from the message type. So I choose say message, and so now anytime that I press space, it's going to tell the message manager, like, to dispatch the message, hey, here's the say message telegram that I want to send out. Can you please do that? And the message manager will send it out to all the telegraphs that are listening for that particular message, which we set up Bob to do so down here. So now if we run it real quick, we'll get our first representation of what our world looks like, and we'll also see Bob. And there's Bob. He's just this poor lonely box in the center of this area. However, later we'll be introducing more people in future videos. So this is just the introduction. And so now I will press space real quick and watch down here on the left. So the second I press it, hi, my name is Bob. So that's perfect. That's just what we're looking for. That means when I press space, the message was dispatched through the message manager, and Bob was listening for that message, and he caught it and knew just what to do with it. And so because he caught it and knew what to do, he returned true, and the message was processed. So next thing we'll do, let's kind of see some autonomous movement going on. It's not so much autonomous, I guess, as much as it is just passing messages on. However, it's still pretty cool to see some motion happening without pressing anything. So we're going to set this up by saying travel position dot set, and this is going to be 0 and -3. And then this is going to be +3. And then flipping this is going to be vice versa. So -3, 0. And then +3, 0. So you'll notice a few things here. So that travel position vector 2 that I had set up here. And remember, if Bob's or a person's position does not equal the travel position, or the travel to position, then they will begin to move in that direction in a linear fashion at a linear velocity. So now that we have that set up, we need to make sure that we return true for handling those messages. Return true because he took that message. Oop. Okay, so now we have even more messages that Bob is able to handle. However, he's not aware of them yet. So there's another method that we're able to use, and it's just an extension of the add listener. It's called add listeners, and you'll notice that it has a different kind of method signature. This kind of it takes in a telegraph as usual, but it also has this int ellipses, where there's like int ... That means you can put as many integers in here as you want. It's just kind of an overload. So we have, we want go up, and I'll just kind of copy and paste this. Go up, go down, go left, and go right. Okay, so now you can see that I have 4 in here now, and that's kind of what we're looking for. And because we don't want to wrap over too much, I'm going to fold that line. And so now Bob will be listening for 5 messages. Same message, go down, go up, go left, and go right. And in order to send those messages in, we're of course going to need some way to provide those messages to the message manager when we want them to. And so I'm going to do message manager keys.left, right, up, and down. And this is going to be go left, go right, go up, and down. Okay, perfect. So now those messages will be able to be dispatched. So now if I hit play, oh, I should probably close this other instance. Okay, here's Bob. He's in his world. Now I'm going to press the up key and notice what happens. Oh, did I set that right? Go up. He's listening. Why isn't that working? Oh, right. That's my fault. So he does have this update method. So like anytime you have this object, I need Bob update delta. There we go. That was a little embarrassing, but moving forward. So now Bob is going to be updating his location, and because I'll press up now, and look at that. He moved right to that spot. And that is because he had the go up message and his travel position changed, and so he had to go up. And so this isn't really something you want to use for like a movement system. So when you have like message.dispatch key left, you don't want to use that as a continuous like, oh, this character is moving left, this character is moving left, this character is moving left, because that will just kind of bog up the message dispatcher, and you don't really want to do that. Granted, the message dispatcher does use polling to avoid garbage collection, which is also a good point to bring up. Don't ever keep a reference to the messages you're using as for that reason, because they'll get destroyed and you won't know when they'll get destroyed by the message dispatcher. However, you can kind of see like the second he receives a message, things change and he acts accordingly. I'm just pressing one key at a time and he'll just keep moving. I'll press space. Hi, my name is Bob. I'm going down. I'll press space. Hi, my name is Bob. And that's just because the travel position changes after that's already happened. So that's just kind of a basic look into how you can begin passing these messages around. Although you should, again, not use this so much as like a movement system. You should use it as a way to communicate messages and make things that are event driven. So like if something happens in your game, then you can send out a message and act accordingly, which is really nice, because then all you have are these telegraphs that are listening for these messages, and you can even set up your screens to be implement telegraphs, and then they can also listen for messages and whatnot too. So it's as easy as that. And there was one more thing, and I honestly think I forgot to mention this. Where is it? So yeah, typically I believe message manager.update. I should have had this in here. However, I don't think I need it because of the way LibGDX is set up with the get instance. If you have your own message manager or message dispatcher, then you need to make sure it's updating. Otherwise, the instance that you're using, the get instance, the regular default one, will update automatically because it's built into like the LibGDX core, like with working with the AI. So with that, I hope you guys enjoyed the video so far. In the next video, we're going to be interacting with like more event-driven stuff rather than just moving this box around. We're going to have a few boxes coordinating with each other, and so then you will see a little bit more of an autonomous view of how to coordinate events in your game and like how events can react on events and then some. And you can also see how to set like delayed messages or particular messages that get scooped up by other entities, and that way you can handle all these crazy situations, and it's a really good way to make things flow in your game. So with that, hope you guys enjoyed the video again, and like, comment, subscribe as usual, and I'll see you in the next one.